Hello, guys. So, welcome back from break. I'm sorry I'm not here today. I will be back on Thursday. Um, I believe you guys left off. We've done exponential growth and decay, the story problems as well. And then you guys also did writing arithmetic and geometric sequences. So you might want to go back in your notes. This was the homework, so I'll let you go ahead and grade it. This is a video, so feel free to stop and pause for whatever time you need. If you need to rewind it, of course you can rewind it. We are going to continue in the notes, and then afterwards you're going to do the homework. Now, keep a hold of this homework. You'll turn in both sets to me on Thursday or Friday whenever I see you. So just make sure that you have it, you've graded it, and then we'll just, again, as I said, you'll just turn it in the very first thing. The notes we're going to go over today is graphing. So we're going to go into actually graphing these exponential functions. The first question, I was going to be your POD, kind of looks like this. So I'll kind of go over it since that's what we're kind of hitting up. Right now, remember with graphing, you can always go to a T-chart. It is always available to you. I'm going to go over some of the kind of like ways to graph without a T-chart today, but if you forget, remember, it doesn't matter what graph you're graphing. We can always go to a T-chart, you know, plug in a bunch of numbers and see where it plots on the graph. All right. So this is our exponential. Remember that it doesn't really matter what the factor is. The critical point or our initial starting point will always be at 0, 1. So it doesn't matter that this is a 2. Now that's going to change when we start doing it. I'll talk to you in a little bit. The reason why, just as a reminder, is if you plugged in 0, it doesn't matter. Any number to the 0 power, whatever it is, will always equal 1. That's why it could be any number out there is always going to be at 1. All right, so that spot is our kind of critical point. This is a growth function. So our critical point, and there isn't any transformation, is at 0, 1. The asymptote is always at y equals 0. So he starts off right here, meaning he's going to get real close to this graph, but he's not going to go over that line. So he'll get really, really, really close to the graph, but not actually cross it. So you got something that gets close to this, and then this is growth. We'll go over how Malman found that out real quick on this lesson. So again, you could plot in points and find it. Our domain are the x values. So as you can see, the blue graph goes to the left, the very far left. That would be negative infinities. And he moves off to the right. Now, yes, he's also going up, but he is moving off to the right. So our domain is negative infinity to infinity. That's the interval notation. If you have the other one, you would have written it like this. All right. Our limit actually comes with the y. We do not go below the 0 line. In fact, we don't even touch 0. So the lowest it goes is 0. And the highest it goes, well, it goes up forever. On this side, at least, it's going up. So we'll have y values that head up. So that would be our range. If you're writing it, remember, we do not want the equal sign this time because he can't actually equal 0. Again, he only gets close to 0. So there's our number 1 review. Jump into number 2. This one finally gives us transformations. So at this point, our critical point isn't at 0, 1 like we like it. I'll talk to you about where it ends up falling, but this one's just asking for the 4 transformations. So looking at this, we have this negative that's out in front. Remember, that is going to be a reflection over the x-axis. Remember, for reflecting over x-axis, we do that guy first. So you might want to say this guy will happen first. I will first reflect. So if he was heading up, he is now reflected and heading down like that. All right. Still heading into the 0, 0 for an asymptote though. All right. The next number I see is this 3. He is also that initial value when we were writing equations. So what does that really do to our actual thing? Remember, he is multiplying, so that is going to be a vertical. And in this case, it's 3. It's a big number, so it's a stretch, because on the outside, we do exactly what we think. Stretch. And then it's by 3. So make sure you put the by 3. All right, so that's a vertical stretch by 3. That 2, remember, we'll talk about later, is going to be, that's how we know it's exponential. He's going to be the one that determines whether we have growth or decay, just so you know. Moving on, this positive 3, he's up there with the x. We're going to go the opposite direction. So to the right is positives. We will now go to the left. So this would be left 3. And then finally, at the end here, we have this negative 4. He's not with the x on the outside. So that would be us going down 4. So that's how we're going to shift our graphs. And we're going to use those shifts. They're going to help us to graph as well when we're doing all this. All right, so getting to the components of it. So here we have the A value. He's our initial value. He actually tells us a lot of information. If he's negative, he'll reflect over the X. If he's positive, he stays the same. He's also going to tell us where our critical point kind of starts at. Not our y-intercept completely, but we're going to look at the y-intercept and then it's going to move from there. So that's the point we're going to use. And then he also does the vertical stretching and shrinking. All right, so he's the reason that it moves off of 1, basically. So H is up at the top. Notice that's a negative because we do the opposites. So that's our left-right movement. The K is our up and down movement. And then that B, I told you that number right there, he actually tells us our growth or our decay. If that number is bigger than 1, it's a growth function. If that number ranges between 0 and 1, we've got a fraction decimals that are less than 1, we're looking at a decay. So he kind of tells us our general shape of like, okay, we have a growth function or we have a decay function. Well, I can draw it. Give it a second. So those are going to give us our basic shapes is going to be the B. A is going to be telling us where that critical point kind of falls initially, and then we'll do the up and down movement. Now remember, when we do the up, down, left, right movement, that asymptote is following me. So you kind of see how we do this. All right, so first off, we're going to kind of fill in the box. The box kind of helps us on how we're going to graph. So this determines our growth or decay. I'm looking at this. This number is bigger than 1, so we have a growth function. So I know my general shape should kind of look like that. Should be going up to the right. All right. I'm going to turn around. This, that y-intercept, it's going to start at 4. Now, it's not going to stay at 4, but it's going to start at 4. So if I go to my graph, I'm going to go 1, 2, 3, 4, and I'm going to put a dot. All right. So originally, I'll draw my asymptote, which is at 0. That means that because of this stretch, I've gone from 1 away to being 4 away. And that's going to stay with me when I move. So wherever that dot moves, my asymptote is going to always be 4 distance away from that dot at the bottom. All right. So then I'm going to turn around. I'm going to leave the true y-intercept right now blank because I'll have to plug in 0 and find out where he really crosses the y-axis at. This is like the initial starting. So now I'm going to do my transformations. So we already did kind of the 4. We've already stretched it. So this is a vertical stretch. I already have that dot on the graph. I'm going to move that dot. So please make sure it's in pencil. So vertical stretch by 4. The transformations to that dot now that I have them is I'm going to go right 2 and I'm going to go up 1. All right, so I'm going to take that dot. I'm going to group it with the asymptote. I'm going to go right 2, 1, 2. That doesn't change my asymptote, but when I move up 1, my asymptote, noticed he moved up 1. So he's no longer at 0, he's at 1. So now I can answer that following question, where's the asymptote? Well, he's at actually y equals 1 now. All right, to get that y-intercept, as I said, I'd have to plug in 0 for x. So again, we get a calculator. This way I don't have to do it on everything, but I can go ahead and do it on this one. So we're going to go ahead and plug in 0. 0 minus 2 is negative 2. And then I'm going to plug this into the calculator. Remember that that caret symbol is how you're going to get the exponential. And then make sure you move off of it when you do the +1. All right, so just remember, if you want to get an exponential, it's that button that has the caret symbol. And then you need to hit the arrow to move off of it to put the +1. So just a couple buttons. All right, when I did this, I got 2. So I can come around here and say this is at 0, 2. So now I have another spot, 1, 2. It's going to come down and hit here. And at this point, I could probably graph it. I got a good idea. It's gross, so it needs to head up like that. And it needs to come down without touching the 1, but getting really, really close to the 1. There's kind of my graph. So again, domain is pretty much going to stay the same. It's going to be negative infinity to positive infinity. The range, however, will change. My asymptote is at 1, so the lowest it goes is 1, and then he goes up to positive infinity. And then let's go ahead and talk about the end behaviors. They're kind of unique. As we go to, remember this is positive, that means to the right. So when I look at the right, he is heading up. So he's going to positive infinity. He's heading up. This one's negative, that means to the left. As this graph goes to the left, he gets really, 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 really close to 1 without ever touching it, which means his limit actually equals 1, meaning he heads towards the number 1. It might be 1.000001, but he's getting really close to 1. So there's your end behavior. All right, as I said, you can pause this. I would give this one a try, see what you can fill in, and then come back in here and check to see how I actually solved it. All right, so hopefully you've paused it. You have a couple of your answers. Starting off, my depending if I have a growth or decay, remember that's this b value, he is less than 1. That means that I have decay, and that means that my graph will head down. So it's going to be up on the left and down on the right instead. The y-intercept is if you want to plug in the 0 value. I like to do that at the end. I don't like doing it at the beginning. My starting point is at a half. So I'm going to change my unit measurements. I'm going to say this is 0.5. That way he's at across. Actually, maybe let's actually keep it at 1. The reason why is I'm going to have to move this, and it's better if I can count by ones. So we'll just move that half down to the halfway point right here. Now that's where he's starting. Keep in mind that asymptote originally starts at the 0, 0. So when I transform, I'm going to connect them together. Now it's in purple. It's not staying there. That's just the start where I start at. And he's half a distance away from the asymptote, so we'll keep him a half a distance. All right. We know that we are going to do a vertical shrink in this case because it's smaller by a half. We've already done that. We kind of have it set up. Now I'm going to do the movements. So we have this +4, which means we would actually go left 4. And then we have this -3, which means we will go down 3. So at this point, I'm ready to move. So I'm going to take my dot and my asymptote. I'm going to go to the left 4. So 1, 2, 3, 4. And then down 3. So 1, 2, 3. Notice I was going down by halves. So watch out for that. All right, so that's where that dot is. I'm going to move that asymptote so that the asymptote fits on the page. He's officially there. All right. Turn around, I can start answering this. So there's my asymptote. I'm going to count that. That's at 1, 2, 3. So he's at -3. So I got y equals -3. This is, let's go ahead and get that y-intercept now. So one time I need to use my calculator now. And this goes to the 4th power -3. So this is what I'm typing into my calculator. With it being fractions, I do have a tendency to put parentheses around both those fractions, just to make sure that the calculator doesn't accidentally think it's up at the top of the numerator or something. All right, and I got a fraction as an answer. Please make sure you convert it to a decimal because I want it as a rough decimal. This gives me -2.84. So close to 3, but not quite there. So I go 0 and then -1, 2. So he is, because of this graph, he looks like he's a line. If I zoomed out, he wouldn't be so dramatic. But I can go like this, and then he's going to somehow, wait a minute, I'm graphing this the wrong way. Forgot I was doing decay. Yay me. All right, I can get here. I can do this. All right, let me pause for just 1 second. Sorry about that interruption. I had some people working outside I had to go deal with. All right, so let's get this dot where it was supposed to be. This is supposed to be down if I can get those down to 2.83. So it should be getting closer to the 3. This one's a half, so he's a little bit up. He's higher than this guy, just so you know. And then decay, got so used to doing growth so much, should be heading down, getting closer and closer and closer and closer. This guy should be heading up to this side. It's going to look shallow right now because imagine the window's zoomed, but if you zoomed it, it would kind of go like that a little bit. All right, so he will shoot up off into the left-hand side. All right, our domain, like I said, he's pretty much consistent. He's going to go left, he's going to go right. There's no holes. There's nothing stopping this from going left and right. As for going up and down, he doesn't actually live below the -3. So the lowest he gets is -3. Remember, he never actually gets to -3. He gets close to it, but he doesn't actually get to it. So these are kind of the two different forms, whether you want to do interval notation, and I've kind of flipped it on domain and range, but you get the gist. You can do either one of those. All right, let's talk about those end behaviors again. Remember, when it says to the negative infinity, it's talking on the left-hand side. So if I look at the left-hand side of this graph, he is heading up to the positives. So he's heading up, meaning positive infinity. And we look at the right-hand side. What is happening on the right-hand side? Well, he's getting really, 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 really close to -3. So that limit will head to -3. It doesn't mean he touches it, it just means he heads that way. All right, at this point, please take out the homework, start working on this, try to get what you can done. When I see you next, we'll go ahead and grade it. Thanks, bye, bye.